So I'm hoping y'all have had a chance to get through the warm-up. So let's take a look at what your answers should have been. Now I have a mistake on this one. It's not the pink one. Oh, why? Why is it not the pink one? Or, let me see if I can pull it out a little bit. Oh, I said it's not the pink one. I make mistakes too. I'm very happy to see you guys talking about this. If you've got questions, please let me know. Mikayla? Okay. So if we just take a look at your properties for number 1. Did you factor out the 1/2 before you went any further? And did in parentheses you have x minus pi? Okay, so we're okay on that. Then amplitude is -3/2. Period would then be 4 pi, so each section is pi. And our shift is going to be up 1 and actually to the right pi. So far, so good? So what I did here is I said my graph starts to the right pi. So this is my first section. And then I go out pi from that. And I also have to remember to go backwards as well. Sine starts in the middle. And as my sign is negative, it goes down from there. And then that means it goes up on the other side. Can't quite read your face, Mikayla. Did you have like a smile? You have a frown? If you have a frown, what I am thinking that you would have done is you didn't do your shift to pi. I did shift. But if you have I see what you're saying. That's why what I do a lot of times is you'll actually see me kind of mark to myself, start. Okay? Yeah, you did all of your markings correctly, but then you went back to the origin or like back to the left to start your graph. She's like, yeah, sure, whatever you say. Let me kind of be clear with you guys on something. If I don't know where you started to draw your graph, I can't tell. Did you accidentally draw a regular cosine graph? Did you shift your graph the wrong direction? Did you do a positive instead of a negative? I cannot tell where your mistake was. So I cannot give you partial credit for anything other than period length, sections, and vertical shifts. So the parent function, the horizontal shifts, the starting, that I cannot give you credit for. So you've got to give me as much information as possible so I can give you as much credit as possible. Okay? Because if you mark on your start, I can at least knock one more thing out, and then we can determine, did you do the wrong parent, sine or cosine? Did you go the wrong direction? Helps me figure out how much you actually knew. Because otherwise, just looking at one of these random graphs going, I don't know what I did. You knew what you did? What did you do? Oh, okay. That's special. That's special. Sometimes we do special things. A lot of you will probably notice that on your homework, you skipped from a top to a bottom without hitting the middle first. The number of times that happens to everybody, it's not just about knowing the main concepts. It's actually going through the concepts without making any of those silly little mistakes. And that's what's annoying about this class, is there are a lot of opportunities for those silly little mistakes. Okay, let's zoom back out a bit. Any other questions on the warm-up? I really wish I was psychic. I could answer your questions without you saying anything. But I'm not. Yes, David! Mm-hmm. Okay, so for pi over 8, that would be this problem here. Pi over 8 is not marked. Pi over 4 is. And I know that pi over 8 is exactly half of pi over 4. So what I did is I went through and I marked all of my pi over 4s, and then I put a little line smack dab in the middle. And that would be my pi over 8. Okay? And if I wanted pi over 16, I would go smack dab in the middle of that. Maybe on a practice, but not on a test or quiz. Everyone's like, I hate you. I hate you. You'll be crazy. Good question, though. Does that kind of answer what you're talking about? It's not going to be a nice line. There's no way around that. Just know that if this is 0 and this is pi over 4, pi over 8 is going to be smack in the middle. Okay? Yes, ma'am.
So if we leave like the bar with the is that part of the
Yeah. And that's the thing. I use X's or dashes simply because I want to make sure that if I've used points before, and then I accidentally always try to connect those dots, which messes everything up. Okay? If you don't want to mark those, you don't have to. But just like I need the guidelines, without those things there, I screw up so easily, it's not even funny. Okay? Yes, sir. Yep. This is a really good example of what you'd have on your quiz. And your quiz is going to be, I believe it's just 4 questions. I should probably get those printed. You know, sometimes that's helpful if I actually have the quizzes to give you. They're made. Let me just see. Whoops, that's not where it's supposed to go. It's not where it's supposed to go. Why are you doing this? So I'm sorry, I lied. It is 8 questions, which should make you feel a little bit better because one mistake isn't going to hurt you as much. 5 minutes. I'm kidding. I love putting the fear of God in you, and then anything I say after that just sounds so amazing. So you'll have 20 minutes to do the 8 problems. Okay? Yeah, about 10 minutes. Okay. All right. That's a really good question. That puts everything in perspective. Okay. So were there any, you know what? I've started to realize how often I say so. I really need to stop that. It's really difficult to stop. So I'm like, so, were there any questions on your homework? Craig. Number 2. Hang on. Okay. It is question number 2. Okay. Graph paper. I'm a big poop head. I don't have an actual spare graph because I'm a big dork. Hey, wait a minute. Yes, I do. I can print them. Woohoo! It's amazing, this critical thinking stuff. Power of paper. Kill them trees. Just kidding. Nope, but I did post it on Canvas. I made it. So I don't want that big. I want this big. 8 per side. And I'm going to sneeze. Am I going to sneeze? Oh, good thing I moved the microphone away. That would have been really painful. Okay. My high-pitched squeaky sneezes. Better than my dad, who sounds like he's going to blow up the room when he sneezes. Oh my gosh! All right, your question was number 2. And drawing on these smaller graphs is actually so much easier to get the curves. Trust me. So number 2 says cosine of 2x minus 3/2. First thing I'm going to do here is I'm going to do my vertical shift, which is going to go down 3 halves. So that's 1, 2, 3 halves. That's 1.5. Was that the O? I heard a couple of those. Ugh, okay. What is my amplitude? 1. The amplitude is the number that's out in front. So the amplitude is 1. So go 1 up, 1 down. What is your period? Pi, because B is 2, so the period is 2 pi over B, so the period is pi. Each section would be what? Pi over 4. Now, the beautiful thing about this, I don't have any horizontal shifts. That makes my life quite a bit easier. I will start then at the middle, and I will go every pi over 4. And then I will draw my graph. Cosine, does it start top, middle, or bottom? Top. That's top, middle, bottom, middle. Top, middle, Oh, did we win last night? We did win? Wow. So now it's 3 and 3. Apparently we do much better at the Astros field than our own, so. Sorry, I just all of a sudden I went from to Baby Shark to Nats to World Series. You know, that was my train of thought. It's kind of scary. All right. Does that answer your question? Okay. Uh-huh. Nope, don't want to do it. I will do it. I'm kidding. I'm kidding. Number 13 says the cosine of 3x. Any up and down movement? Nope. So I'm going to be, there's my so again. Ugh. They get a shock collar every time I say that. Amplitude is going to be 1. I didn't go up and down, so I just go up here. Now I've got that song in my head. Baby shark doo 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 doo. Baby shark doo doo. So someone's going to have to go back and watch this video and listen to me sing Baby Shark. Yep, I'm doing that. What is your period here? 2 pi over 3. Oh, that's weird. If I want to find my section, I'm going to take 2 pi over 3 and do what? Multiply it by 1/4, because dividing a fraction is very difficult. Multiplying by a fraction is easy. So that gives me pi over 6. Then I'm going to have my x's, because remember, each of these tiny little lines between the 0 and the pi over 4 is either a pi over 6 or a pi over 3, which means those are all the ones that I want. Again, we're extremely lucky. There's no left to right shifts on this. It's just focusing on amplitude and all that jazz. Cosine is going to start where? Top, middle, bottom, middle, top, middle, bottom, middle, top, middle. And then baby shark doo 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 doo, baby shark doo 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 doo. Baby shark doo 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 doo, baby shark. Mommy shark doo 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 doo, mommy shark doo 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 doo. Yes, I am doing that. On tape even. He's like, what? Craig. Yeah. Because if you see, I don't actually kind of go, I'm like, ooh, what's pi over 6? And then I just keep marking that distance. I try to do this with the least amount of work possible. Because the more work, the more thought you do, the more chances you have for messing up. It's a sad statement. The more steps you take, the more likely you're going to trip. So, yes. Number 12. And then we will move on, because I do want to make sure we get through today's stuff. Number 12 says sine x plus pi over 4 plus 3/2. You should be pretty good with the fact that you're going to go up 3/2 and then up 1 and down 1 from that. So far, so good? This is number 12, which you can't even see that I was writing on that. Okay, yeah, that helps. What is your period going to be for this? 2 pi, which means each section is going to be pi over 2. Trick here is I do actually have a horizontal shift. What am I doing? I'm going to go left pi over 4. If I go left, I'm off my graph. So that's a very difficult thing to do. Instead, I'm going to go to the end of the period. I'm going to go to the 2 pi. And from 2 pi, I'm going to go left pi over 4. So now that is going to be my start. And my section is pi over 2. If you have trouble figuring it out, take a look with your finger. Pi over 2 is about my finger width apart. So that's going to take me here, here, and here. Those are my clear points. Sine starts where? Middle. And sine typically goes up, but I'm off the graph that way. Means I'm going to go down, going the other way. I'm going to get that song in all of your all's heads. And always carry it off the graph. That's fine. That's perfectly fine. I don't even think that way. That's okay. All right. That's sine and cosine. We'll have a little bit more practice with that later on, but I do want to talk to you guys right now about tangent and cotangent. And really, with those two things, it basically covers a majority of what we're doing this unit. The rest of that comes from that. It's just kind of like saying, all right, so now you know sine, let's do cosecant, which literally says kind of put your points on the sine graph and then do the opposite, which is a lot easier than it sounds. These are your last really big different parent functions. So if you've got your unit circle, or if you've got that sucker memorized, which is even better, let's take a look and think about what tangent is. What is tangent? Tangent is y over x. So if I've got 2 points, x and y, tangent is y over x. Just like we did with the sine, this axis, my horizontal x-axis, represents your angle, and the vertical axis represents what your function is. So that will represent the tangent. At the angle 0, what is your tangent? Tangent of 0 is 0. Beautiful. I'm going to make my life a little bit easier to start with. I'm only going to do the things that I know give me zeros, ones, and other stuff. I'm not going to do like root 2 over 2. I'm not doing those. What is the tangent of pi over 4? 1. What is the tangent of pi over 2? Undefined. Guess what goes here? Vertical asymptote. Boom shakalaka. I had a lot of orange juice this morning. I'm in a great mood. What is the tangent of 3 pi over 4? -1. Tangent of pi? Someone remembers his rules from last year. What is the tangent of 5 pi over 4? And what's really great about these graphs is they should kind of help you solidify what your different values are. For example, if you don't remember what the sine of 0 is, you can remember, well, the sine graph starts at 0. If you don't remember what the cosine of 0 is, cosine graph starts at 1. Tangent and cotangent graphs follow patterns just like the sine and cosine do. The problem is they're not really waves. These guys work with asymptotes. I want everybody to just kind of pause for a second and watch how I draw this. Because for some reason, tangents and cotangents cause a lot of difficulty with people drawing. What I found to be the easiest is to start at the middle and to curve up, and then start at the middle and curve down. So curve down, curve up. It's almost like a cubic function, but not quite. Take a close look at what I've got up here. I have to draw an arrow on each end of each line. You must fill the graph from the top to the bottom. No stopping, just kind of short in the middle. You got to go all the way. Craig. Okay. Got to fill up the whole graph. Go from 0 to 2 pi. Little arrows to tell me what's going to keep happening on the ends of that. Arrows at the ends of each section. Now, looking at that tangent, I want you to think, what is a period for the tangent? Remember, a period is how long it takes it to repeat itself. Pi. Do you guys see why that's pi? I start in the middle going up. The next time I come to a middle going up is at pi. That is one full tangent period. He looks weird. But no matter what, tangents and cotangents both will have a period or start with a period of pi. Now, I've got this saying thing about amplitude. Problem is, amplitude technically only deals with waves. And while that's a repeated pattern, it's not really a wave. And an amplitude goes to the highest point. Well, these are going to go to infinity no matter what. So it's not really the amplitude that we're talking about here, but it's going to be a line where we put all of those upper critical points, just like we had for sine and cosine. Only now my graph's not going to stop there. So that idea stays the same. So it's just not technically called an amplitude. Few things talking about tangents. Tangents start at a middle point and go up. Asymptote is straight in the middle of your period. Cotangent. How do we do cotangent? X over y, right. What then is the cotangent of 0? Undefined, because 1 over 0 is undefined, which gives me a vertical asymptote. What is the cotangent of pi over 4? 1. Cotangent of pi over 2? 3 pi over 4, bless you. You see we're picking up that pattern again. Cotangent of pi, undefined. There's another one of my beautiful little asymptotes. Cotangent of 5 pi over 4. And we're picking up that pattern. Some of you guys in here are sitting here going, holy crud, how do these other folks know what she's talking about? The answer to that is they have seen this before. This class is geared for those of you who have not seen this before. So please, do not hesitate to ask a question. Okay? This is the cotangent graph. It goes up to the left and down to the right. Again, filling from top to bottom, making sure that we have arrows on each of those lines. Let's list out a couple of differences between tangent and cotangent. Tangent and cotangent are both going to have a period that starts out as what? Pi. And just like with the sine and cosine, if you have a b, to determine your period, you're going to divide that by b. Here, for each of your sections, what will you do? Take whatever you get for your period and divide it by 4. Now, to sketch the asymptotes to find your critical points, you need to remember that if I'm talking about the tangent versus the cotangent, what does the tangent start with? A 0 point. So a tangent starts with a 0 point. The next section goes up. The next section is an asymptote. The next one's down, and then the middle. So the tangent graph, what you're looking at, has this as a start. Start, and it goes up. Cotangent starts with what? An undefined, with an asymptote. Cotangent is going to start and end with an asymptote. Tangent starts and ends with a point. Tangents start and end with a point with an asymptote in the middle. Cotangents start and end with an asymptote and have a point in the middle. Cotangents go the opposite direction. Cotangents go down. So cotangents start with an asymptote, and then they go down. And if it starts with one, the middle is the other. So if it starts with a point, the middle is an asymptote. Then you can plot your critical points in graph. Please make sure that you always show arrows. All of them. Make sure you fill the graph. Fill. I know how to spell fill. I'm in past 2nd grade. Fill the graph top to bottom and from 0 to 2 pi. Making sure that you always do that. All right? Ready, Freddie? You'll see some people writing it down. I get so excited. I love to move fast. Woo-hoo! Looks like some of y'all need to have orange juice in the morning. Perk yourselves up. Who needs coffee? Orange juice does the trick. Ready? Okay. Is that annoying? Is that annoying at all? A little bit? We're not going to halfway do this. We're going to fly right into the whole shebang. Understanding that a tangent really doesn't have an amplitude. What are we thinking of for the amplitude for this one? Top and bottom, and what would it be? 1. Again, your b is the number between your tangent and your variable. What's b? 1. If b is equal to 1, what is my period? Pi. Because remember, for a tangent and a cotangent, the period changes. It is now just pi over b. That's one of the big changes for tangent and cotangent. And if my period is pi, how big is each section? Pi over 4. Do I have any shifts? To the right, to the right. I'm going to put what I think are the easy lines first. I'm going to do my middle line. Boop, 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 boop. I'm going to go up 1. I'm going to go down 1. And I'm going to go, can I go to my right pi? I can do that. That's on my graph. That means this right here is going to be my start. From there, I'm going to do all of my sections out pi over 4. I got to remember to do it both directions. This function is what type of a graph? Sine, cosine, tan, cotangent? Tangent. Where does tangent start? A middle with a point. So it will go middle, up because it's positive, asymptote, bottom, middle, and then I'm going to go the backwards. So if this was top, middle, this down here is going to be bottom. That is going to be an asymptote, top and middle. Making sure, guys, I'm going to be looking. Did you put an arrow, especially on that first and last line? There's the answer. David, if you need to stand in the back of the room to stay up, you can. Go ahead. I understand. I see you trying. I see you trying. And ladies and gentlemen, that offer is open to anybody. If you're having difficulty staying awake, I've got clipboards in the back of the room just for that case, so you can stand in the back, get the blood moving a little bit. More than welcome to. I appreciate that you are trying to stay awake. Whoosh. Cotangent. Tell me something about this graph. Ooh, nice. This one will start with an asymptote and end with an asymptote. Tell me something else about this graph. It's going to shift up 1. So I'm going to do that. Boop, 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 boop. So much more fun when you make noises. What else can you tell me? Period is 2 pi. Because for the period, we're going to take pi divided by that number. Yeah, you got to be real careful with that. If the period is 2 pi, what is each section? Pi over 2. You guys are missing an easy one. What's my amplitude? 1. Those are usually I go for the vertical shifts and the amplitude first because I think those are the easiest ones. And I'm all for taking the easy way out. Is this guy shifting left or right at all? No, so that means I get to put my first spot here. My sections are pi over 2. There are the rest of my pieces. I was already so wonderfully told that a cotangent starts with an asymptote. What direction does cotangent go? Up or down? down, and that means at the next point, it'll be at the top, next point middle, next point bottom, asymptote. Feel free to move your paper to graph that. I'm just trying not to, so that you can still see what I'm doing. Only it makes it super hard to graph. Okay? How y'all doing? He's like, nope, don't want to do this anymore. I want you guys to try number 7 for me, please. Start to finish, all on your own. Do it. Oh, no. Our answer for number 7 is this doodad here. Take a good look at that. Guys, that would be a good look at it. Questions on this? Okay. Were you okay with the vertical shift up? Amplitude of 1.5. So top and bottom. Okay, so you started at pi, and from here out you're okay? Then what you need to understand is it's just a pattern. So we go middle, top, asymptote, bottom, middle, top, asymptote, bottom, middle, top. So if I've got a middle top, that means bottom, asymptote, top, middle, bottom, asymptote, top, middle, bottom. Do you see the pattern that I'm talking about? A tangent goes up on the right, down on the left. That means if you have your asymptote, you're just going to keep following that same pattern going the opposite direction. Thad? Because you see how my 2 is already factored out? With a 2 already factored out, I don't need to do anything with this. That's what we want to see. We want to see b times x minus, I don't know what variable I said. Minus, what variable were we? I think that's c. We'll put a c there. That's what we want to see. So it's already taken us to that point. So we don't need to do anything more. Okay. All right. Let's do one more. So try this one on your own. Try to get all of your facts, all of your pieces. Work together. That's okay. Maybe. Kind of. Boop. Here we go. Big heavy sigh. My gosh. Okay, what we're going to do now, simply because of the way our timing works out, I am going to stop us here. I'm going to give you a classwork worksheet. All I'm going to ask you to do is to do the sine and cosine problems on that worksheet. There's tangent and cotangent mixed in there as well. You're just going to do the sine and cosine. When you're done with those, you will turn it into me. The next one page in your handout packet is your homework for tonight. Just do the sine and cosine problems. All right, understand what I'm asking you to do? We're going to focus on sine and cosine because that's what you're going to have on your quiz next class. Just sine and cosine. Okay.